In this video, I'll be introducing the quadratic equation. Please keep in mind that I've made this video the way I see fit and not in accordance with any particular syllabus. So please check with your teacher and textbook and don't rely on this video to tell you everything you need to know. In terms of maths notation, this video uses the dot instead of the cross as the multiplication symbol. Let's start with a square which measures 5 by 5 units. The area of any shape is always in units squared. We can express the area of this square as 5 times 5 units squared, or 5 squared units squared. Either way, the area of the square is 25 units squared. So, what if we make one side longer by 1 unit? Well, in that case, we can express the area of this rectangle as 5 times the sum of 5 and 1. In other words, we can express it as 5 times 6. Hence, the area of the rectangle is 30 units squared. What if the sides have lengths of x units? In that case, we can express the area of the square in units squared as x times x, or x squared, or x to the power of 2. Now what if we make one side longer by 3 units? Well, then the area of this rectangle in units squared is x times the sum of x and 3. We can simplify or expand this expression. X times x is x squared, and x times 3 is 3x. So we add the 2, and the area of the rectangle is x squared plus 3x units squared. Let's give it a test and see that this works. Suppose x equals 2, so we just substitute 2 in for x. That makes 2 times the sum of 2 and 3, so 2 times 5. The result is 10 units squared. Now for the other expression. That makes 2 squared plus the sum of 3 times 2. That makes 4 plus 6. And again, you don't need your calculator to figure out the result, which is 10. As always, the area of the shape is in units squared. So this works, and that's nice to know, and we can now move on. Let's take the rectangle we just had earlier and make the other side longer by 4 units. The area of a rectangle still is one side multiplied by the other, so it's the sum of x plus 4 multiplied by the sum of x plus 3. At this point we should note that before things get complicated, mathematicians like things to be as simple and clutter-free as possible. In algebra, we just leave the multiplication symbol out unless it is necessary to understanding the equation. For example, if you think about it, 3x really is 3 lots of x, so 3 times x. But we just leave the multiplication sign out because it isn't necessary. There are some examples of this on the right. So now we'll expand these brackets. The easiest way to do this is using the FOIL method, which stands for first, outer, inner, last. So for the first step, we multiply the first 2 numbers of each bracket. The first 2 numbers are x and x, so we multiply them. This gives us x squared. For the outer step, we multiply the outer numbers of each bracket, so x and 3, which makes 3x. For the inner step, we multiply the inner numbers of each bracket, so 4 and x, which makes 4x. For the last step, we multiply the last digits of each bracket, which are 4 and 3. This makes 12. So the result is all of these added together, which is x squared plus 3x plus 4x plus 12. Of course, 3x and 4x make 7x, so we can simplify and say that the product of x plus 4 and x plus 3 is x squared plus 7x plus 12. Hence, the area of this rectangle can be expressed as x squared plus 7x plus 12 units squared. We can test whether or not we've done our calculations correctly by plugging in a value for x. In this case, I'm going to say that x is 6. So the sum of 6 plus 3 multiplied by the sum of 6 plus 4. That means 9 times 10, which is 90. And let's just note that down at the bottom. Now 6 squared plus the sum of 7 times 6 plus 12 makes 36 plus 42 plus 12. Again, this makes 90, so our expression for the area of the rectangle works. We have just discussed 2 fundamental parts of the quadratic equation. Let's start by just thinking about the term quadratic. You probably know that quad means 4, quadrilateral means a 4-sided shape, and a quadrat is a square or rectangle. This reminds us of the rectangle we had earlier. The 4 reminds us of the fact that there are 4 terms in the brackets of x plus 4 and x plus 3, x, 4, x, and 3. The square reminds us of the x squared in the quadratic equation. Yes, X squared plus 7x plus 12 is a quadratic equation. Quadratic equations are always in the form of ax squared plus bx plus c, in which a is never 0, but b or c may be 0. If a was 0, it'd just be a regular linear equation in the form of y equals mx plus c. This means that the defining property of the quadratic equation is that it has x squared in it. For example, earlier we had x squared plus 7x plus 12. Having x squared is the same as having 1x squared, so we'll just put a 1 in front. We can thus deduce the coefficients or parameters by looking at this equation in the form of a quadratic equation. A is 1, b is 7, and c is 12 in this equation. Now let's discuss what type of factors make quadratic equations. Earlier I said that the defining property of a quadratic is that it has x squared in it. If it doesn't have x squared, it's not a quadratic. So here are some examples of factors of quadratic equations. When you multiply any of these pairs out, you will get a quadratic. I call them factors because they multiply or expand to form a quadratic equation. Other people prefer to call them brackets. Expanding is when we have a set of factors or brackets and we multiply them out. Remember to use FOIL to make a quadratic equation. Then there is a fairly straightforward example below. However, never forget to pay close attention to the signs in front of numbers. X minus 2 is much like x plus negative 2, and negative 2 times 5 is negative 10. There are, of course, many things we can do with quadratics. This video is just meant to introduce the most basic concepts, the equation itself, and the brackets. In other videos, you'll be learning how to find x, how to graph quadratics, how to manipulate these graphs, and how to go from a quadratic equation back to its factors. This video is registered under Creative Commons 3.0 BY-NC-SA license, which means that you are free to download, remix, and share this video as long as you give credit to youtube.com/understandingmaths, and your creations, adaptations, or copies are distributed non-commercially under the same license.